So now in this video we're going to make a NOT gate circuit with a mechanical switch, a push button switch in this case. I was going to make a video using a integrated circuit that has NOT gates in it. That's the best way probably to make a NOT gate in most situations, but unfortunately I fried both of the integrated circuits I had. So I'm buying some more, waiting for them to come. I was looking for an alternative, and this was the first schematic I came across of my old schematics where I have an alternative NOT gate. So even though this is probably the worst way to make a NOT gate in a practical circuit, there's still a lot of principles involved here that apply to other circuits, so it's still a good circuit to learn and understand. So to begin with, we have a little bit of an odd definition for 1 and 0 in this circuit. So whenever you're dealing with logic gates, you got to define what 1 and 0 is. Usually 1 is like close to 5 volts and 0 is close to 0 volts. Here we're going to call, when it says 1 in the truth table, that means on. So you can see the LED is on. Current is flowing through it. The switch is off. Current is not flowing through it. If it was, then the current would have an easier path to ground right there, and the LED would be off. So when the switch is off, it's open, the LED is on, as we can see here. When I press the button, and it's making iffy connection. So even though it looks like I'm pressing it when the LED is on, I actually lost connection. It's doing really bad right now. So in any case, there we go. Switch is on, and so you can see that current path right there. Whatever's going through the resistor is going through the switch to ground. Much easier path than the LED. So the switch is on, current's flowing through it. The LED, as you can see right there, is off, 0. And now I'm guessing that probably most people figured out why this is the worst way to make a NOT gate. So we have the LED on right there. You can see how much power we're using. This is fine right now. That's how much power we expect with 5 volts, 220 ohm resistor protecting an LED. The problem is when we turn the LED off, we expect the current to drop to nothing for the most part. And when I get a good press of the switch, for some reason it's really making a bad connection. There you can see I turn the LED off, and the power went way up. We're using like 80%, I'm estimating, more current than when we were just powering the LED. More current's going through the switch by a lot. And so that's a bad way to make a practical circuit. But there's a lot of circuitry where you got something that's on, you take power away from it, and so there's still power going, but usually it's very, very small to control it, whereas this is the least practical, but still this is probably easier to understand because it's simple circuitry, so it'll help you understand those more complex circuits. But in any case, this has gone on long enough. This is my short video series, so I'm going to end it there. Thanks for watching.